Hi. In this series of problems, we will start with chapter number 2 in a thermodynamic book. The information of this thermodynamic book, I will have it in the description below. So in this series of problems, we will start to explore the concept of energy, kinetic energy, potential energy, work. These are very important concepts to understand, to practice, so we can use it to build on other thermodynamic concepts and help us solve other thermodynamic problems. So here we will start with problem 2.1, and here we have a baseball has a mass of 0.3 pound mass. So as you can see right here, we have a pound mass. It's very important to make your units clear and obvious. That will help you, aid you to solve the problems without a mistake. So here we are asked to what is the kinetic energy relative to home plate of a 94 mile per hour fastball in units of PTU. So we want to find the kinetic energy in PTU units. So here we are given, So here we are given a mass of baseball of 0.3 pound mass and a velocity of 94 mile per hour. What are we asked to find? We are asked to find the kinetic energy of the baseball in PTU, British thermal units. So what's the solution in here? So here the kinetic energy equation is 1/2 mass times velocity squared. So this object have a mass and it have a velocity associated with. That means that this object have kinetic energy. So before we start, now we need to make sure that our units are consistent. So here the mass is given. The velocity is given, but the units are not consistent. The unit of velocity is mile per hour. So in this case, we need to use conversion factor. So here we use these two conversion factors to get feet per second squared. So what will happen here is a mile will cancel with a mile, an hour will cancel with an hour, and we will be left with feet per second. And when you plug in the values into the calculator, it will give you 137.87 feet per second. So plug in the given values into the kinetic energy equation, and you will have, and what you will have is 2851.22. But pay attention to the unit. So the units that we have is pound mass and feet squared and second squared. So that's what we have here: feet squared, second squared, and pound mass. All right. So our goal in here is to change the pound mass to pound force. And how can we do that? We will use the gravitational constant. Now the gravitational constant or the unit factor conversion from pound force to pound mass, from pound mass to pound force is this unit that we have in here. All right. Now, so what will happen here, as we said, the pound mass will cancel with a pound mass, and a second squared will cancel with a second squared, and here you will be and a feet will cancel with a feet squared, and you will remain with 1 feet, and we will have a pound force, and that's the unit that we have in here, and which is the unit of energy, because energy is what? What's the unit of energy? It's joules. Joules is what? Is Newton times meter. Newton is the equivalent to it is pound force, and meter equivalent to it is feet. So that is the correct unit. So right here, the kinetic energy, we divided it by the gravitational constant. So what is this gravitational constant? The gravitational constant is 32.2, and pay attention to the units. It's pound mass feet divided by pound force second squared. So now you will ask yourself, do we divide the kinetic energy equation or whatever equation in US customer unit, we divide it by gravitational constant or we multiply it by gravitational constant? That depends on the units of the equation. So here in kinetic energy, we want to cancel out pound mass. So having the pound mass in the numerator won't help. So that's why we want the pound mass to be in the denominator. So in order for us to flip these units, we will divide the equation by the gravitational constant, and that's what we did in here, and we were able to get the desired unit of pound force times feet. But we're not done here. Here we need to we need to use another conversion factor to convert pound force times feet to British thermal units. So we will use this conversion factor, which is 1 PTU is equivalent to 778 pound force times feet. So here the pound force will cancel with a pound force, and your answer will be 0.114 PTU. Problem 2.2. An object whose mass is 400 kilogram is located at an elevation of 25 meter above the surface of the earth. For gravity of 9.78 meter per second squared, determine the gravitational potential energy of the object in kilojoules relative to the surface of the earth. So here let's write down what is given. Here we are giving a mass of an object of 400 kilogram. We are given that the elevation or height of this object is 25 meter above a reference or datum, which is the surface of the earth, 25 meter, and the gravity to be 9.78 meter per second squared. It's very important to sketch or draw your problem. The more it is a good practice, because the more the problem become more complicated, it's a very good thing to write down what's given and at the same time to sketch what is given and what need to be found. In this way, it's better to visualize the problem. So let's say that we have the surface of the earth, which is the datum. And let's say this is the datum, which is the relative, that's the height 0, the initial height, let's say. And we have an object. It does not matter what's the shape of the object. That object is placed or located at an elevation of 25 meter above the surface of the earth. So that's what the problem is given in a sketch, in a drawing. So here we are asked to find the gravitational potential energy of this object. So the potential energy is mass times gravity times height. So the mass is given to us as 400 kilogram. The gravity is given to us as 9.78 meter per second squared, and the change in height is given to us as 25 meter right here. So now we will plug in these values into our calculator, and it will give us 97,800. And the units in here, as you can see, kilogram times meter per second. Kilogram is mass, meter per second square is acceleration. Mass times acceleration is force, which is the unit of Newton times meter. Now we know that work is force times distance, or Newton times meter, and that's the unit of joules, the units of energy. So, but here we are asked that we need to find the potential energy in kilojoules. So we divide the 97,800 by 1,000. It will give you 97.8 kilojoules. All right, problem 2.3. Here we have an object whose weight is 100 pound force. And remember, weight is a force. Experience a decrease in kinetic energy of 500 feet pound force and an increase in potential energy of 1500 feet times pound force. The initial velocity and elevation of the object, each relative to the surface of the earth, are 40 feet per second and 30 feet respectively. If the gravity constant are given as 32.2 feet per second squared, determine the final velocity in feet per second, the final elevation in feet. As always, as a good practice, write down what is given, sketch what you have, write down what you need to find, and start your solution. All right. So here we are given what? We are given the weight, W, as 100 pound force, the kinetic energy as 500 feet times pound force, the gravitational potential energy as 1500 feet times pound force, the initial velocity as 40 feet per second, and initial elevation of 30 feet. All right, so what are we asked to find? We are asked to find the final velocity in feet per second and the final elevation in feet. All right, so here we will have the surface of the earth, which is the datum or the reference. And we are told that we have an object. Its initial at a height of 30 feet, we will have its initial velocity as 40 feet per second, and as we mentioned, its height will be 30 feet. Here, the object will move up. Now, why did we say that the object will move up? Because in the problem, we are told that the object is experiencing a decrease in kinetic energy. So here the object is losing, or in other words, using its kinetic energy to move the object up against the gravity, and that will cause that you will have a decrease in your kinetic energy. And from the conservation of energy, we don't have a loss, but what will happen is the kinetic energy will convert its used energy to potential energy as we increase in elevation. So the object will reach at a certain height, and at that certain height we will have a kinetic energy of 500 feet per second, feet times pound force, and a potential energy of 1500 feet times pound force. All right, so now let's start the solution. So the kinetic energy equation is 1/2 mv squared. Now remember, here we are using US customer unit, and as we mentioned in previous problem, we will divide this by the gravitational constant so we can flip the units, and we can cancel the pound mass and convert it to pound force. So here we are given the kinetic energy. We are not given the mass, but we are given the weight. We need to find the final velocity, and we are given the initial velocity of the object. All right. So now we know that weight is mass times gravity, and here we need to solve for mass. Mass is, we will solve for it, so we will have weight over gravity. The weight is given to us as 100 pound force, and the gravity given to us as 32.2 feet per second squared. And that pound force divided by feet over second squared, this is the unit for sludge. Now what we will do, okay, so here we solved for the final velocity using algebra. So the 2 will move to the other side of the equation, from division become multiplication, and the mass will move it also to the other side of the equation, from multiplication to division, and the initial velocity will move it to the other side of the equation, so we can leave the final velocity by itself on one side of the equation, and when it moves to the other side, the negative will convert from negative to positive, and that's what we have in here. And to get rid of the square root, to get rid of the square, we square root both sides of the equation. All right. So here we plug in the given values that we have, and now pay attention to something. Here the kinetic energy is negative because we said that there is a decrease in kinetic energy. That's why we put a negative in here to indicate that we are having a decrease in kinetic energy. All right. So the final velocity will be 35.74 feet per second. So you'll ask yourself, how did we, from these units like feet squared and second squared and feet, pound force, and sludges, how can we get the unit of feet per second? And that's what we will see. All right. So remember here we said that feet per second squared and second squared, right? Now the division that I have a yellow circle in it, we will convert it from division to multiplication. And when we do that, we will flip the units. So the pound force per second, the pound force per second square, instead of being on the top, will be on the bottom. And the feet, instead of being on the bottom, it will be on the top. And that's what we're going to have in here. So now we can cancel the pound force by pound force. Sorry, I put the strike in the wrong location. So the pound force will cancel with the pound force, and you will be left with feet times feet will give you feet squared over second squared, which is the same as this one right here. So when we take this outside of the square root, it will give you an answer of feet per second, which is correct. And this is a good way to check if the equation that you used or the algebraic solution that you did to find for the final velocity is correct or not. Now we need to find the potential energy. The potential energy tells us is what? Mass times gravity times the change in elevation, right? Okay. So now we are given the potential energy. We are given the initial height, which is 30 feet. We need to find the final height, the mass, and the gravity. We have these two values. So here we will use algebra to solve for the final elevation, h sub f. And here we will plug in the given values. And we will get an answer of 45.03 feet. All right, problem 2.4. At 2.5 by 3.5 by 6 inch, so this is a volume brick whose density is 120 pound mass over feet cube. Slip off the top of a building under construction and falls 69 feet. For gravity 32 feet per second squared, determine the change in gravitational potential energy of the brick in feet times pound force. So this is a simple problem. As always, we write what's given. We have a volume. And the volume, to keep our units consistent, we will change an inch to feet, and that's by dividing it by 12. So 2.5 divided by 12, by 3.5 divided by 12, by 6 divided by 12. And when you plug this into your calculator, it will give you 0.0304 feet cube, or cubic feet. Density is 120 pound mass over feet cube. And from the unit, you can know that density is mass over volume. The height is 69 feet. So what do we need to find in here? Here we need to find the gravitational potential energy in feet times pound force. And here we are using US customer units. So what's the solution? So we know that potential energy is mass times gravity times height. And here we don't know what's the mass, but we know what's the gravity, we know the height. So let's find out what is mass. So let's go back to density. So density is mass over volume. So let's solve for mass. So we will move volume to the other side of the equation from division to multiplication. So that will give you mass times volume equal to volume times density. The volume is given to us that we found to be 0.0304 cubic feet times pound 120 pound mass divided by feet cube, and here feet cube will cancel with a feet cube and you will left with pound mass. So here we will plug in the given values. So mass, we found it to be 3.64 pound mass. The gravity is given to us as 32 feet per second squared times 69, which is the height, which is given, times the conversion factor, where we want to convert the pound mass to pound force. So so that's why we divide the gravitational constant, and we use, instead of 32.2, we use 32 to keep it the same value as this one. And here we flip the units. That's why we divide the potential energy equation, we divide it by the gravitational constant. So in this case, the pound mass will cancel with a pound mass, second squared will cancel with a second squared, and a feet will cancel with a feet. So here you will be left with feet and pound force, and when you plug this into your calculator, it will give you 251.56 feet times pound force, and that is what we need to find. Alright, problem 2.6. An object of mass 1000 kilogram, initially having a velocity of 100 meter per second, decelerate to final velocity of 20 meter per second. What is the change in kinetic energy of the object? Now, before we write down what's given and what we need to find as a solution, in this problem, we are told that the initial velocity is 100 meter per second. This object decelerate and the velocity decrease. So that means we lost, or the kinetic energy is lost. So now when you have an object that decelerate, that energy can be transferred to friction, to drag, and other forms of energy. So in this case, we can safely assume that the final answer should be negative, because you have a decrease in kinetic energy. Alright, so now let's write what's given. So we have a mass of an object that is 1000 kilogram. The initial velocity v sub I is 100 meter per second. The final velocity v sub f is 20 meter per second. And if you look at the units are all consistent. What do we need to find? We need to find the change in kinetic energy in kilojoules. So let's do the solution. So we write down the kinetic energy equation, 1/2 m and the change in velocity squared. So the mass is given to us, the final velocity is given to us, the initial velocity is given to us. And when you plug in the given values into the equation and plug it into your calculator, the answer should be negative 4800 kilojoules. Alright, problem 2.7. So in this problem, we have a 30-seat turbo prop airplane whose mass is 14,000 kilogram, takes off from an airport and eventually achieve its cruising speed of 620 kilometer per hour at an altitude of 10,000 meter for gravity of 9.78 meter per second squared. Determine the change in its kinetic energy and the change in the potential energy of the airliner, each in kilojoules. So now let's write down what is given. Here we are given a mass of airline of 14,000 kilogram. The final velocity, v sub s, is 620 kilometer per hour. To keep our unit consistent, we will use two conversion factors. The first one to convert from hour to second, and the second one to convert kilometer to meter. So here a kilometer will cancel with a kilometer, and an hour will cancel with an hour, and you will be left with meter per second. And when you plug this into your calculator, it will give you 172.22 meter per second. The height is given to us as 10,000 meter. What we need to find is the change in gravitational potential energy and the change in kinetic energy for the airliner. So the solution in here, so let's solve for the change in kinetic energy. So we write down the kinetic energy equation, 1/2 m v squared, the change in the velocities. So now the mass is given, and the final velocity is given to us, and we converted from kilometer to meter per second, which we are given. The initial velocity is also given to us, but in the problem we are told it takes off from an airport. So when it starts at rest, then it starts to take off. So the initial velocity here is 0. So you plug in the given values into the equation and plug it into your calculator, and you will be given this value in joules. We divide it by 1,000 to get this value of the kinetic energy in kilojoules. All right. So now we need to find the change in potential energy. So if we can take the takeoff RAM to be our zero elevation, and as the airplane goes up on the skies, it starts to increase in elevation until it reached an altitude of 10,000 meter. So here in this we have the mass, we have the height, and we referenced its initial height. So we plug in the given values, plug it into your calculator, and you will get this value in kilojoules for the potential energy. All right, problem 2.8. Here in this problem, we have an automobile having a mass of 900 kilogram. Initially moves along a level highway at 100 kilometer per hour relative to the highway. It then climbs a hill whose crest is 50 meter above the level highway and parks at a rest area located there. For the automobile, determine its change in kinetic and potential energy, each in kilojoules for each quantity. Kinetic energy and potential energy. Specify your choice of datum and reference value at that datum, and let G, gravity, 9.81 meter per second squared. So what are we given here? We are given a mass of an automobile of 900 kilogram. Its initial velocity is 100 kilometer per hour. So to keep our units consistent, we will use the two conversion factors to convert from kilometer per hour to meter per second. So here a kilometer will cancel with a kilometer, an hour will cancel with an hour, so we will be left with meter per second, and the value will be 27.77 meter per second. The height or change in elevation, h, is 50 meter. what what do we need to find in here? We need to find change in gravitational potential energy in kilojoules and change in kinetic energy in kilojoules. So what's the solution? So first let's write down the change in kinetic energy equation, 1/2 mv squared. The mass is given, the final velocity is given to us, because in the problem it tells us that when the automobile climbed a hill whose crest is 50 meters above the level highway and parks at the rest area, so the velocity reach then the vehicle velocity becomes 0, so that is its final, and because at rest, and the initial velocity is given to us as 100 kilometer per hour, which we converted to 27.77 meter per second. We plug in the given values, and the answer will be negative 347 kilojoules. Now remember, when we have a value of negative, it means that this object used its kinetic energy to move an object, and that energy is converted to a potential energy. So the energy is not lost, but it's converted to another form, potential and others, like friction force and other. So that will be the change in kinetic energy. Now what about the change in potential energy? So the mass, we know it. The initial height, which will be our level highway datum, it will equal to 0. And when it started to climb the hill, it reached to an elevation of 50 meters. Now we plug in the given values into the potential energy equation, and we plug this into our calculator, and we will be given 441 kilojoules. All right, problem 2.9. We have a vehicle, crumple zone. I don't know if you've seen this before, but you can Google this. Car manufacturers use a crumple zone, and they use it to create an impact and to see how the car behaves when it impacts the crumple zone, so they can better design their cars to handle impact. So here we are told the vehicle crumple zone are designed to absorb energy during an impact by deforming to reduce transfer of energy to occupants. How much kinetic energy in PTU must a crumple zone absorb to fully protect occupants in a 3,000 pound mass vehicle that suddenly decelerate from 10 miles per hour to 0 miles per hour? So here what are we given? Here we are given a mass of an automobile of 3,000 pound mass. All right. The initial velocity of this vehicle is 10 miles per hour, and here we will use the conversion factor. A mile will cancel with a mile, and an hour will cancel with an hour, and here you will be left with feet per second, and the value will be 14.66 feet per second. The final velocity is given to us as 0 mile per hour, which is 0 feet per second. All right, what do we need to find? We need to find kinetic energy in PTU must a crumple zone absorb. So what the crumple zone need to absorb the automobile energy. So we need to find the change in kinetic energy in PTU for the automobile in order to know how much the crumple zone need to absorb. So the solution in here, we will use the kinetic energy equation, 1/2 mv squared. And we know the mass, we are given the final, we are given the initial. And when you plug in the given values into the kinetic energy equation and plug it into your calculator, you will be given this value. And as you can see in here, the value is in negative, which means this is how much when the impact happened, the automobile transferred its kinetic energy to the crumple zone, and that's what the crumple zone need to absorb. Now, but pay attention is that the units are not what we want. It's in pound mass, feet squared over second squared, and we need to change the pound mass to pound force. So here we will use the gravitational constant, which is 32.2 pound mass times feet divided by pound force times second squared. Now, if we multiplied the change in kinetic energy by the gravitational constant, you will see that the pound mass in here and pound mass in here, they will not cancel. It will become pound mass squared, which is, we want to get rid of the pound mass. So in this case, we will divide the kinetic energy by the gravitational constant and flip the unit. Whatever is in the bottom become on the top, and whatever is in the top will be in the bottom. So here we will use the conversion factor that we talked about. So here a pound mass will cancel with a pound mass, good, and a second squared will cancel with a second squared, and a feet will cancel with feet squared, and we will be left with 1 feet, and we will be left with pound force, and the value for the kinetic energy will be this value, feet times pound force, and remember, it's a negative, which means that this energy is being transferred to another form of energy. But we're not done here. We need to convert this to PTU, so we use this conversion factor, and a feet pound force cancel with feet pound force, and you are left with PTU of minus 12.88 PTU. All right. In here we, all right, 2.10. It tells us an object whose mass is 300 pound mass experience changes in its kinetic and potential energy owing to the action of a resultant force R. The work done on the object by the resultant force is 140 PTU. There are no other interaction between the object and its surrounding. If the object's elevation increased by 100 feet and its final velocity is 200 feet per second, what is its initial velocity in feet per second? Let g equal 32.2 feet per second. All right, so now let's write what's given. We are given a mass of an object of 300 pound mass. The work done on the object because of the resultant force is 140 PTU. Now, from the problem, we want our units to be consistent, so we divided by this conversion factor, where a PTU will cancel with a PTU, and when we use this conversion factor, we will get the correct unit that we want in feet pound force for work. Now the height or change in elevation is 100 feet. The final velocity is 200 feet per second. What we need to find is the initial velocity v sub I in feet per second. So now let's sketch this problem so we can understand what are we dealing with. Alright, so here we have an object and we have a resultant force or different forces acting on it, and that's its combined force. It's called the resultant force acting on this object. All right, and that is its initial position. Now we don't know how this object reached to its elevation, to its final elevation of 100 feet, but as we know that force times a distant, or this path distant, is work. And this is the object at its final position, and because of the force and the path it went, it used an energy of 140 PTU for the object to move to change its elevation to 100 feet and increase, and its final velocity to be 200 feet per second. So what's the solution here? So here, as you can see, that work is the change in kinetic energy plus the change in potential energy. All right, so work is given, mass is given, final velocity is given, mass is given, gravity is given, and the change in height is given. So here we need to find the initial. And remember that the gravitational constant is 32.2 pound mass times feet divided by pound force times second squared. Now, what I will do in here is I will take the potential energy equation and divide it by the gravitational constant, and we will plug in the given values, and we will get 30,000 feet times pound force, and the unit canceling in here, you can practice it like we did in the previous problems. So in here we will use algebra to solve for the initial velocity. So here the 2 move to the other side of the equation, become multiplication, and because we said that we divide by the gravitational constant, so we will have it in here, and we have the work and the mgh, your potential energy, move to the other side of the equation, which is right here. The positive will become negative, and the mass in here move to the other side of the equation of 300 pound mass. So you plug this into your calculator right here, and it will give you this value, and these are the units that you're gonna have. And from these units, as you can realize, we can cancel the pound mass with a pound mass, pound force with a pound force, and you are left with feet, and this feet and this feet is feet squared over second squared, which is, because here is what? The velocity is feet per second. To the power 2 become feet squared and second squared. So this unit is the same as this unit, so we are in good shape. So now the final velocity is given, and we will move it to the other side of the equation, and it will become from positive, it will become negative, which is this one right here, plus the value that we have in here. And now what we will do is the answer in here, right here, will be in negative. So we will multiply both sides of the equation by negative and take the square root of both sides of the equation to get rid of the squared, and we will have our initial velocity to be 151.85. I hope that you find these problems helpful, and stay tuned for more problems to come in thermodynamics. Thank you very much, and have a wonderful day. Bye-bye.